Hi everyone, I'm Tim Wolf from the Wolf Circle. In this video, I'll explain how to interpret the graphs for displacement, velocity, and acceleration, and at the end of the video, we'll do some practice. First, let's discuss the displacement time graph. So in this graph, the vertical axis represents the displacement in a positive or negative direction. It really doesn't matter which direction you define as positive or negative, so let's just say this direction is positive. So when the subject moves in a positive direction by 2 meters, then the graph also increases by 2 meters. But let's say during this movement, then 4 seconds elapsed. So the graph for this transaction will look like this. The slope of the graph equals the rate at which the position changes, or simply the velocity. So if you increase the slope like this, or make it steeper, then the same distance is traveled, but in a shorter time, so the subject is moving faster, or at a higher velocity. Now let's discuss the velocity time graph. So if you remember from the previous video, acceleration is the rate at which velocity changes. So the slope of the velocity time graph represents acceleration, similarly to how the slope of the displacement time graph equals velocity. So if the subject moves at a constant velocity in a positive direction, then the slope of this graph will be 0. But if the slope is positive, then the subject will be constantly speeding up. And the graph of the displacement time will be a curve like this. Finally, the acceleration time graph. So any positive acceleration indicates an increasing velocity. At constant acceleration, the velocity time graph will have a constant positive slope, while the position time graph will have a curve like this, as we discussed in the previous slide. If the acceleration time graph has a positive slope, then the velocity time graph will have a curved slope like this, as the velocity is increasing by more with every increment of time, and the position time graph will have an even steeper curve. With a zero acceleration, it's still very possible for the velocity to be very high, but it just means that it's not changing anymore. For example, from when a car is starting to when it reaches its maximum velocity, then the acceleration graph will look something like this. Because the rate at which the speed increases slowly decreases as the car reaches a higher speed. And any negative acceleration represents deceleration, or slowing down. From this point on, we're going to go through some practice, but if you feel like you understand everything already, then you don't need to watch the rest of the video. For each problem, feel free to pause the video and try to solve it yourself first. Okay, let's get started. So try this question. Where in this graph is the velocity the highest? Here, you just have to remember that in a position time graph, the slope equals the velocity. So the question's essentially asking, where in the graph is the slope the highest? Between points C and D, then the position and the displacement is highest, but the slope is almost 0. So the velocity is actually very low. But if you go to point B, then the slope is very steep, so the velocity will be very high. So the answer is B. In this example, then you're given two acceleration graphs. With both graphs, then they stay positive until the end, so you can assume that the velocity is always increasing. So for both graphs, the highest velocity will be found at point D, because velocity is given the most time to increase. This is tricky because the solid line is actually decreasing, but as long as it stays positive, then the velocity will still always be increasing. Let's do this last example. The graph represents the path of a human as he walks across a field. Which point on the graph represents where the man changes direction? For this one, a very common guess would be point B, but the velocity before and after point B is still positive. So the person continued walking in the same direction, but just started slowing down. For any change in direction, you have to look for where the velocity is 0 and becomes negative. Thus, the man changes directions at point C. Try and figure out the last question on your own, and the explanation will be in the text associated with this video. For the questions relating to the graphs, it is important to have lots of practice so you can start understanding the logic behind each question. Thank you so much for watching, and I'll see you next time.